Hello, I'm Tyler.
I'm Sam.
Hi, I'm Dave.
And I'm Alex. Not pictured is also Ryan in our group, but he was not able to attend the video.
Mm-hmm. So we chose to do the Tom's Turtle Python project. We took a very unique approach. We decided to do a class definition for our instincts. So all of our turtles in our Python program fall under one extended turtle class, which gives us a unique approach on how we define how each turtle knows every instinct. Yeah. Someone else want to move forward?
So again, talking a little bit more about that is we do extend that base Python turtle object. So typically the way we've seen other groups do it was they created functions for each of the instincts and then passed in the turtle to act on. But instead of doing that, we kind of collapse that syntax a little bit more succinctly. And instead of creating that turtle and passing it in again, we have our own turtle and we call methods on that turtle. So each of the instincts that we see in the original test file, so we go over here, this is our original source file, we see we have, was it star is our instinct that we were calling? Yeah, so we have star there. And if we go over and look at our output, our generated file, we can see that we are calling that star instinct right here, just like what is literally a method. And it looks really nice. We like the syntax of that very much versus calling functions on turtles or calling functions and passing the turtles in, I should say.
Mm-hmm.
So that's the one really unique thing that we did in our project that we were really happy about. So looking at some output, we can see we already generated that test 5 output. So what I will do is I will go through that and we'll run that really quick. Test 5 that output, and we can see here we go. That will just draw a neat little fractal. So let's keep going over and over and over again. So you can see that that does in fact take the source language and generate the target language as specified.
Mm-hmm.
So, what else do we have that's kind of interesting to talk about? I really liked the way that we did the indentation. So every level of code that we saw, what we needed to do was add another level of indentation for nested loops, so on and so forth. So we had a couple different functions that would just do all of that. So we just find, let's say, a new line character and add an additional tab after that new line character. Or just do a bunch of other things, which makes it really nice because you can just call that function, and then when you bubble up to, let's say, the line of code that's actually the for loop, so we have a for loop nested inside a for loop, we call indent on the body of the nested for loop, and then that for loop, which is itself a statement in the language, we call indent on that as well later on. So.
Woohoo!
So we did the whole symbol table thing as well. So when we see something, we make sure that it is in the symbol table. You want to talk about that a little bit more, Tyler?
Yeah, so the symbol table we decided to use was a pretty simple linked list. Basically, we start with a null global variable, and after the first link is added, we just keep adding links to the chain. In our version of the program, we don't support any local variables, so we don't need to delete anything from our table ever. Some small drawbacks to this are, all of our names are unique among the entire program, so instinct names are unique with variable names. So like a turtle can't have the same name as an instinct, a number can't be the same name as a turtle or an instinct, and vice versa. But overall, it's pretty simple. a potential change to do if we were continuing this project would be to maybe use C++ instead of regular C, and then do some stack or QSTL just to make life much easier and make the code a lot simpler. That's the symbol table basics. I think there's 3 different types. There's type 0 for type 0 instinct, type 1 is turtle, type 3 is number, and then all the math operations support using number variables, which verifies that that number was in fact in the table and the type is correct. You can't do any math operations on turtles. You also can't do math operations on instincts. What are some other unique things about that? We decided to add implicit declarations for turtles. So if you ever call a turtle function on a name that was not declared in the symbol table, it is immediately declared in the target language. I think there's an example of that in the test4 file. I don't know.
So what do we have, Carl here? We had Carl here that
so,
was never actually declared.
Yep. So Carl gets popped. If you compile that file, you'll see that Carl gets popped out in the declarations, or not into the target language. Also, kind of the structure of the way our program works is you start with hatch, then all of the instincts, then all of the turtles, then all of the numbers, and then all of the commands, and then there's soup. Can't read the soup.
Yeah. So that's pretty much what we had. I think those are kind of covered a couple of unique things that we did in our files that were worth noting. But the most important, well, to me at least, the most important thing that we did in this project was we used Git for all of our version control stuff. So working on this project with a bunch of different people, we're a mix of on-campus and online students. So having a version control software to work with was very important, I think. But some of the things we did, I mean, you can see in our commit history, when I pull it up here, any moment, is that we do have a bunch of little commits and a bunch of different people working on different things. And that using version control allowed us to do that. And not only that, we also tracked issues with a GitHub issue tracker. So we could see different things. So these are like all of our issues. We're tracking a whole bunch of different things. You can see people are discussing what we need to accomplish. And we have a bunch of different dialogue on here, which, again, using Git allows us to work asynchronously because Tyler's in South Korea. And what's the time difference with you?
14. I'm 14 hours ahead.
So yeah, and I think it's been really great working on this project this way versus trying to copy. Obviously, nobody would do this anymore, but like back in the good old days when people used to copy files and zips and like try and synchronize everything over emails and whatnot, just absolute garbage.
The issues was really nice. So it was my first time using GitHub, and the issues was really nice.
Yeah, because especially like you can reference like your commits inside the issues, and you can see like I think what was the one I was looking at, like symbol table. I can just inside this discussion, I can like I was referencing a commit right here, and you can go and you can see exactly who is making the changes, what changes were made, and again, just using version control allows us to track all the changes, which is really important to me at least, because I can see who's doing what.
Yeah, I definitely agree that GitHub was a very valuable part to this project. Korea's too far to be sending zips over email.
So I think we'd all be kind of curious as to see with the peer review how other groups collaborated if they used GitHub. Feedback on how we did the project in terms of unique names and unique instincts. So yeah, the collaboration I think would be it'd be interesting to see how other people did it with online and campus students.
Mm-hmm. Yeah.
Cool. And then the final thing we did was we did use the GitHub wiki to talk about our source language spec, documentation, and then the context-free grammar, kind of declaring or putting all those things there. And then, of course, just like anything else on GitHub, everybody in the group could modify that or contribute to whatever they so desired, I guess.
Mm-hmm.
So yeah, anything else you guys want to talk about?
I think the class prepared us really well for the assignment.
Yeah, that
Yeah.
one time where Tom was like, this code generation thing isn't going to help you at all in the project. Yeah, you just completely gave it away. So I think everybody can agree on that.
Oh my gosh. Maybe we want to talk about some things we could change in this project for the future. So if there was more time to go back and add more features, I feel like we could change the grammar to better handle a ton of, like a large program as input. So for example, our program we only use a 10,000 character buffer. So if the source file is insanely long, we don't get quite everything. And it doesn't really error out. It just kind of lops off whatever's left.
Yeah, and that's one of the reasons I still had this one issue open saying use dynamic strings. But it's really hard to do that because you don't know how to initialize things. And with dynamic strings, obviously, you'd allocate a certain amount of memory, and then you'd increase that memory as you needed, as opposed to allocating 10,000 characters at once, which clearly isn't portable, but it gets the job done. And Tom didn't ever say that we needed to do anything else other than that, so we're happy with it.
Yeah. I really would like to see this in C++, actually, because there's so many more things we could take advantage of there that we can't here.
Especially like one of the things that when I was thinking about doing this is, let's say you have a for loop and you have a bunch of nested statements or something like that.
Mm-hmm.
So right now what we do is we just build up all of the statements into one big string and then you just kind of return a huge block. But the problem with that is when we want to indent something more, we have to go over the entire line, shift everything to the right, add a tab character, and so on and so forth. But if you had something like a list of statements where you just had an array of pointers even that was associated with a for loop conditional statement, something like that, then you could just build that dynamically when you finally need to actually create the output string. And instead of having just one giant text blob, it would probably be a lot easier and more efficient, not easier necessarily. But
yeah, we could also print the statements into the target language as we read them. Like as we match each rule, we can dump the statement out with like a printf or something that would prevent us from having like anything insanely long, preventing us from compiling, but it would not give very good error detection. And also the indentation would be an issue again with that if we change to something like that.
cool. Well, anything else? I think that's pretty good.
I think that covers everything.
Yay.
All right. Well, everybody who's watching this, thanks. We'll sign off now.